GHGSat satellites and aircraft, an existing and operational system of systems for the detection of methane emissions in the oil and gas industry. GHGSat was established in 2011. We operate our own satellites and aircraft that have been detecting and quantifying methane emissions from oil and gas facilities across the United States and around the world, providing timely and objective data needed to empower better environmental decisions by federal agencies, state and local governments, communities, companies, and individuals. GHGSat currently has 3 satellites in orbit. Our next 3 satellites are under construction and are scheduled to launch next year, towards the goal of a 10-satellite constellation within 2 years. A complementary aircraft-based sensor has been performing operational campaigns for oil and gas operators across North America since 2020. GHGSat's technology is being routinely applied to the detection and quantification of methane emissions to support fugitive emissions investigations and mitigations on behalf of end users in government, industry, and science. This image was taken by a GHGSat satellite in February of this year and shows a methane superemitter in the Permian Basin in western Texas. Our commercial satellites have a minimum detection sensitivity of 100 kilograms per hour, covering a 12 kilometer by 12 kilometer field of view with a spatial resolution of less than 30 meters. This image shows an observation of a methane leak at a compressor station in the Permian Basin taken by the aircraft-based version of GHGSat's instrument. GHGSat's aircraft-based sensor has a detection sensitivity of about 10 kilograms per hour in a 750-meter swath with a spatial resolution of approximately 1 meter. This aircraft sensor complements GHGSat's satellite constellation, an existing and operational system of systems for methane monitoring that is available right now. A compelling new strategy for dramatic near-term reductions in methane emissions combines artificial intelligence with satellites, aircraft-based sensors, and targeted ground monitoring of emissions in a tiered system of systems approach. AI-enabled analytics are applied to data from multiple satellites and relevant ground sources to predict areas at higher risk of emissions. Satellites monitor on a frequent basis, with an emphasis on high-risk areas, detecting very big emissions quickly, about 50% of methane leaked by volume. Airborne sensors are dispatched periodically to survey areas of interest, with emphasis on the high-risk areas identified by satellites. The objective of airborne monitoring is to measure large leaks that contribute the next 40% of methane emissions by volume. Finally, ground surveys will be employed occasionally to detect the remaining 10% of methane emissions by volume. Information is presented to the end user either as standalone data products or as informational layers through an integrated analytics platform called Spectra. For government regulators, GHGSat offers a regulator service that performs satellite measurements of designated facilities within a region of a regulator's jurisdictional responsibility, for example, major shale play boundaries within a state or county. Satellites and aircraft-based sensors can play a significant role in efforts to reduce methane emissions from sources in the oil and gas sector. For more information, please visit our website at www.ghgsat.com. Follow us on social media, or contact us by email at info@ghgsat.com.